沙尼姆。
西安沙尼姆。
哦，the way is 西哈普 and 谭进。
他们来。
Last time we have learned section 4, 6 and section 4, 7. Section 4, 6 is about logical simplification using Boolean algebra. And section 7, section 4, 7 is about how to convert Boolean expressions to truth table form, or convert the truth table to Boolean expressions. So let's continue to review the important things we have learned in this chapter. Variable, complement, and literal. Three important concepts. And product term. Product term is the product of literals, including variable or complement. And we can use AND gate to general or product term. Communicative laws, associative laws are very easy. And distributive law is like this. AB plus AC equals A and B plus C, or A and B plus C equals to AB plus AC. And the 12 rules of Boolean algebra we must remember. We must remember. We should know that A plus A equals A plus A bar equals 1, A and A equals A and A bar equals 0, A double bar equals A, and then A plus AB equals A plus A bar B equals A plus B, A plus B and A plus C equals A and BC, or A plus BC equals A plus B and A plus C. We can exchange their position. De Morgan's theorem, section 4.3. De Morgan's theorem. We must remember. X, Y bar xy bar equals x bar
plus
plus y bar. And x plus y bar equals x bar and y bar. The dot can be deleted. The dot can be deleted. That is the contents of De Morgan's theorem. And substitution theorem. Each variable in the De Morgan theorems, all the 12 rules, of the Boolean algebra as stated, and can also represent a combination of other variables. It's very important. If you want to simplify a Boolean expression, we may use the substitution theorem. Then, Boolean analysis of logic circuits, including get the Boolean expression of a logic circuit. The method is begin at the input, at the leftmost or uppermost input, and work toward the final output. Then writing the expression for each case. That is the Boolean expression for a logic circuit. And we can also construct a truth table for logic circuit. So if we start if we want to Boolean analysis of a logic circuit, that is mean we can get the Boolean expressions for the logic circuit or construct the truth table for the logic circuit. Boolean analysis, it means we should get the Boolean expression of the circuit or construct the truth table of this circuit. Then we said we had analyzed the logic circuit. Section 4.5 simplification using Boolean algebra, including the basic laws, the 12 rules, and the theorems of Boolean algebra. The basic laws contains commutative laws, distributive laws, associative laws, and the rules include the 12 rules. Theorems include De Morgan's theorem and substitutive law, substitutive theorem, right? We must use the few escapes possible to implement a given expression. That is the meaning of simplification. And the method and the result is not only the one, maybe has several methods or several results. Then section 4.6, standard forms of Boolean expressions. First, SOP, the sum of products, forms. Two or more product terms are summed by Boolean addition. Then the resulting expression is a sum of products, like this: AB plus ABC, ABC plus CBE plus B bar C D bar. They are both the sum of products form, abbreviated SOP. We must note that all SOP expressions can contain a single literal term, such as A bar, B bar, C bar. They are also on SOP expression. Second, a single O bar can't extend over that one variable. So this expression is not a sum of product form. It's not. Three, more than one variable in a term can have an O bar. For example, A bar and B bar. This expression is an SOP expression. Then the important contains domain. Domain means the set of variables contained in the expression in either completed or uncompleted form. For example, in this expression, the domain includes the set of variables A, B, and C. And the second expression, the domain is the set of variables A, B, C, D, E, A, B, C, D, E, 5 variables. That is the definition of domain. And implementation of an SOP expression. First, use the AND gate, and then use the OR gate. All product term is produced by an AND operation, and the sum of two or more product terms produced by an OR operation. So it is very easy. AB plus BCD plus AC. First, we use AND gate to generate the product. Yes, the product term. AB use AND gate. BCD use AND gate. AC use AND gate. And then use OR gate to add the 3 product terms. Yes. We can also use NAND gates. Use NAND gates to implement an SOP expression. NAND gates like this. This is the second method to implement on SOP expression. Use NAND gates. There are four NAND gates.
1, 2, 3, and 4.
3
And total.
and 4. So there are 4 NAND gates.
Two NAND gates.
Then,
One OR gate.
if we know the general expression, we can convert the general expression to SOP form. SOP form. The method is like this. Use the distributive law. And use the distributive law and the substitutive law theory. Substitutive theory. This one plus this one over equals this one bar and C bar, right? This one bar and this one and C bar. We use the De Morgan's theory. Use the De Morgan's theory. And A plus B double bar equals A plus B. A plus B double bar equals A plus B. And then use the distributive law. We know that A plus B and C bar equals to A C bar plus B C bar. Conversion. That is the conversion of our general expression to SOP form. Then, if we know the general SOP form expression, how can we convert it to our standard SOP form? For example, this expression is on general SOP form. And the domain is A, B, C, D. So, it is not on standard SOP form, because the definition of a standard SOP form expression is all the variables in the domain appear in each product term in the expression. For example, A bar, B bar, C bar. In this product term, where the variable D, the literal D, the literal DOD bar, does not contain in this product term. And C is not contained in this product term. So this expression is not a standard SOP expression. The standard SOP expression is like this. A B bar C D, A bar B bar C D bar, plus A B C bar D bar. Because all the variables in the domain appear in each product term. In each product term. So it is on a standard SOP expression. Also this expression. There are three variables in the domain. A, B, C, and all the variables appear in each product term. A, B, C, C bar, A bar, B bar, C bar. So it is also on standard SOP expression. Then how to convert all product terms to standard SOP? Product terms. If any non-standard SOP expression can be converted to the standard form using algebra rule 6 and rule 4. A plus A bar equals 1. A and 1 equals A. And the method is like this. A, B bar. There are three variables in the expression. And so the product term A, B bar is not a standard product term. It's not a standard. So we can use rule 4, Boolean algebra. Rule 4. A, B bar, and 1. 1 is equals C plus C bar. C plus C bar. So the last expression is A, B bar, C plus A, B bar, C bar. That is the standard SOP form of A, B bar. Standard SOP form. If several variables are not included or contained in the product term, then we must repeat step 1. Repeat step 1 until all resulting product terms contain all variables in the domain in either completed or uncompleted terms. For example, if the domain includes 4 variables A, B, C, D, then A, B bar is not the standard product term. So we must add C and D to this product term. So we first use rule 4. This is rule 4. A, B bar equals A, B bar 1. Then 1 equals C plus C bar. 1 equals to C plus C bar. And then use the distributive law. Distributive law, we know that this expression equals to A, B bar, C plus A, B bar, C bar. Right? Use the distributive law. And then A, B bar, C equals A, B bar, C and D plus D bar. A, B bar, C bar equals A, B bar, C bar and D plus D bar. So at last, the final expression is A B bar C D plus A B bar C D bar plus A B bar C bar D plus A B bar C bar D bar. That is the final SOP form.
We can make it less.
Then binary representation for standard product term. Binary representation. For standard product term is equal to 1 for only one combination of variable values. For example, A, B, C, D. A, B, C, D. If A, B bar, C, D bar equals 1.
So A equal 1, B bar, B
Yeah.
equals 0, C equal 1, D equals 0.
Yeah.
Because if D equals 0, D bar equal 1, we have to make it 1.
So A, B bar, C, D bar had a binary value of 1, 0, 1, 0.
First is 1, on. Second is 1, 0, 0, 1. Third is 0, 0, 0, 0.
Yeah, yes, this example.
Yeah.
One, 1, 0, 0, 1, 0, 0, 0, 0. Okay, section 47, converting SOP expression to truth table format. Or convert or truth table format to all SOP expressions. How to convert SOP expression to truth table format? There are three steps. The first step is list all possible combinations of binary values of the variables in the constructed truth table. And then the second step is convert the SOP expression to standard form. That is why we should know how to convert all general a binary expression, a general expression to a standard form SOP, to a standard SOP form. That is why we should learn, or why we should know, because in step two, we must use this method. And the third step, place a 1 in the output column for each binary value that makes the standard SOP expression of 1, and place a 0 for all the remaining binary values. For example,
0, 0, 1.
You are on truth table. Construct a truth table. So 0, 0, 1, 1, 0, 0, 1, 1, 1. There are three variables. So the combination, the all possible combinations include 8. Yes, 8.
2 to the power of 2 keeps to 8.
Yes. And standard, it is a standard SOP expression. So we omit this step. And step 3, we know that the three terms equals 1. So it is 0, 0, 1, 1, 0, 0, 1, 1, 1. And the others are 0. This expression is its own general expression. So we must convert the expression to a standard SOP form. First, the first step lists all possible combinations. The domain includes 4 variables, A, B, C, D. So there are 4 possible combinations. 4. That is 16. There are 16 possible combinations. 16. There are 16.
Yes, 2 to the power 4, so 16. 4 base
From 0 to 15.
Yes.
And the second step is convert the expression to a standard SOP expression. How to convert this expression to a standard form? To a standard SOP form. Means convert this expression to a standard SOP form. Also we know very good. Yeah, very good. Very good. 沙弥。 They are same.
So
Yeah.
A, B, C, D.
Yeah.
A, B, C, D, right?
Okay. You know how to convert? Okay.
So 1, 1, 1, 1, 1, 1, 1, 0.
First, we must know that the domain include A, B, C, D, four variables. So each product term must contain the four variables. So we first we know that according to the distributive law, we know that this expression is equivalent to AB plus ACD, right?
Yes, sir.
And then this term, C and D are not included in this term. So we must add the two variables to this term. How to add? First, AB
C.
equals to AB and 1,
Yes.
right? And 1. And 1 equals
C plus C.
1 equals to
C plus
AB.
C
C
plus
plus
C bar.
C bar. Right?
Yes, sir.
C plus C bar equals to 1. You know? And ACB. So they equals AB
C.
C plus
AB.
AB
C bar.
C bar. Distributive law. This expression is equal to this expression. And plus ACB. Then for the same method. It equals to ABC and D plus D bar. D plus D bar. And this product term equal to ABC bar, D plus D bar. And this product term equal to A, B plus B bar and CD. Because this D plus D bar equals to 1.
Yes.
1 and A equals to A. So this expression is equivalent to the product term.
Yes, sir.
Product term. So
A, B, C,
then,
D.
then according to distributive law, we know that this expression is equal to A, B, C, D plus A, B, C, D bar. Right?
Yes, sir.
Right? And this expression is equal to A, B, C bar, D plus A, B, C bar, D bar, plus A, B, C bar, D bar. Right?
Yes, sir.
Plus this expression is equivalent
A, B, C, D.
A, B, C, D. But A, B, C, D
We
is
have already.
increased. It's
So we can write one.
so we don't need to write it again. And the last product term is A, B bar, C, D. A, B bar, C, D. So there are five product terms in this expression. 5 product terms. 1, 2, 3, 4, 5. 5. That is the standard SOP expression for this general expression. Step 3. Write all the binary values combination which make the expression equal to 1. So if A, B, C, D equals 1, then 1, 1, 1, 1. A, B, C, D bar 1, 1, 1, 0. 1, 1, 0, 1. 1, 1, 0, 0. 1, 0, 1, 1. So we only need to write the five product terms equal to 1, and the others equal to 0. Then the truth table is gotten. That is how to develop a truth table from the expression. The second, if we know the truth table, how to determine the standard expression. There are also 3 steps. First step is list the binary variable, the input variable for which the output is 1. Okay, let's have a rest for 10 minutes.
Okay. Respect मला सांगा तुम्ही respect दिलं तुम्हाला respect इल एकर करून की ऑर्डर दिला तुम्ही की ऑर्डर दिला না আমি আর বইটা দেখছি এই লাস্টে সবাই তো থিঙ্ক প্যাড ইউজ করে কোরাই স্ক্রিন ওই এক জেনারেশন তাহলে আমাদের চাপ দিচ্ছে Bashak রাইলো না কাছে और की रैकेट खेलते जाओ की ঘুমলে যাবে যেটা করার কাম হবে না তো এই যে ওদের কই যে পান কিন্তু ওদিন দেখো এক সপ্তাহ আগে দেখছি ওই রুমে রেখে দেন যে পান ওদের তো আমি ক্লাসে কইও দিছি একবার এই যে আমি বই দিছি এনে হাস করে দিয়ে রুমে গেছি যাই দেখি ওদের গুটে গুটে ধরে জ্যাক ধরা কিছু জানো চুরি আমাদের করে সমস্যা নেই কিন্তু অন্যের ধরা খেয়ে গেল এটাই সমস্যা যেদিন পান নাই আল্লাহ দিন সবাই লয়ে গেছে নাকি ঠিক আছে একদিন ভালো হয়ে গেছে দেখছিস তোরে আমি না কাজ করি না চুরি তো ভালো হয়ে গেছে ভালো আর বাকি তো আমি কোনো বাজে কথা করি না কিন্তু তুই প্রচুর পরিমাণে বাজে কথা বলিস বুঝছিস La 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 A plus AC bar AB BC bar times মোটামুটি কেউ ভালো হতে গেলে ভালো হতে চাইলে আর মাত্র ভালো হতে চায় না ভালো হতে চাইতেছি কিন্তু ভালো হতে দিতেছে
আমি যদি ভালো হতে চাইছি আমার ভালো হওয়ার তো আমি
খারাপ কোন জায়গায় আমি করবো
তাহলে তো বুঝে দেবো মন মানসিকতা
আমার মন মানসিকতা খারাপ
মাইন্ড চেঞ্জ করতে হবে
আমার মাইন্ডে কোন জায়গায় না এটা
You can ask your house.
আমি তো সেই উচিত কথা বলি খারাপ হয়ে যাই
উচিত কথা বললে সবার কাছে খারাপ কথায় তুমি খারাপ
এর লাগে আমি চুপচাপ নাই তুই মানে এমন একটা উদাহরণ দে না আমি সত্যিই জানতে চাই যে
তোমাকে ফাইন্ড আউট করে নিতে হবে নিজেকে
এখন হইতে পারে তুমি ওইটা তোমার দ্বারা খারাপ লাগছে দেখে তুমি কিছুটা খারাপ আমি কই না এটা বলো না আমি এটা বুঝেছি মানুষ পরিপূর্ণ না A, B, C. I do this one.
Okay.
And
Okay.
B1.
Okay, continue to review
Statement B, C.
section 47. Determining standard expression from a truth table. If we know the truth table, we can get the standard SOP expression. The first step is to list the binary values of the input variable for which the output is 1. The output is 1. And then convert each binary value to the corresponding product term. If it is a variable, then if it is corresponding to what? If the value is 1, then the corresponding literal is a variable. If the value is 0, then the corresponding literal is a complement. Right? And step 3, add all product terms of step 2. For them, like this. First one, list all the combinations, all the possible combinations. That is the truth table. And the first one is list all binary values which corresponding output equals 1. This one. So 0, 1, 1, 0, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1. Mission. Please see the PPT. The first step, list all the binary values which corresponding output equals 1. This one. So the first step is list this, and this. Right? And the second step, convert to the product term. This binary value, the corresponding product term is A bar, B, C. Right? This one is A, B bar, C bar. This one, A, B, C bar.
Yes.
A, B, C. So there are 4 product terms.
A, B, but C, but A, B, C, but A, B, C.
Yes. And the third step, sum the product term. Sum the 4 product term to generate the standard SOP expression. Right? Like this. Like this. So from this we know that if we know the truth table, then we can get the standard SOP form expression. But do you know why we should know how to get the standard SOP expression? Why we should convert our general expression to our standard SOP expression? What do you know? Today I will tell you the reason. For the kernel map, because in the kernel map we must use the standard SOP form in the kernel map.
What is standard map?
Let's continue to learn. Our kernel map provides a systematic method for simplifying Boolean expressions, and we have produced the simplest SOP or POS expression. POS, we don't need to know.
SOP is sum of
product of sums. Product of sums.
This reverse. So like we have to go from there to there.
Yeah.
This is SPOS, product to sum. And this SOP is from there to there.
Second, our kernel map presents all of the possible values of input variables and the corresponding output. Kernel map. 3. Our kernel map, the kernel map is an array of cells, in which each cell represents a binary value of the input variable. Represents a binary value of the input variables. 4. Kernel maps can be used for expressions with 2, 3, 4, and 5 variables. 2, 3, 4, and 5 variables. We can use kernel map to express. 5. The number of cells in the kernel map is equal to the total number of possible input variable combinations. For example, if there are two variables, how many cells in the kernel map?
4.
Two variables. Two variables. 4. Yeah.
2 to the power n.
Yeah. 2. 4. Right. And if there are 3 variables,
8
in the kernel map, then there are 8 cells. If there are 4 variables,
16
16. And 5 variables,
32
32.
6
32. Okay.
6 is 64.
5 variables.
Is enough.
5 is the maximum value.
We can use
We cannot get 6 variables in a kernel map. In a kernel map, it is very complex. For example, the three variable common is on array of 8 cells, like this. Like this.
0.
Yes. AB 0, 0, 0, 1.
Yes, sir.
But the third is not 1, 0. It is 1, 1. And this is 1, 0. Because we must make each adjacent cells only have one bit different. For example, 0, 0 is the same,
Yes.
and 0, 1 different, but only one bit different.
Yes, sir.
Because this is 0, C is 0, 0, C is 0. Like this. 0, 0, 0 is A bar, B bar, C bar, right? And 0, 1, 0, A bar, B, C bar. The two product terms only one position are different.
Yes, sir.
B bar, B, and the other two variables are the same. The other two literals are same, right? A bar, C bar, and then these two cells, 0, 1, 0, 1, 1, 0, 1, 1, 0, and the two variables are the same. The two literals are the same. Only these literals are different, right? So we list in this order to make each cell are adjacent. Then 1, 0, 0 is A, B bar, C bar. 0, 0, 1 is A bar, B bar, C. 0, 1 is 1, A bar, B, C. A bar, B, C. 1, 1, 1, A, B, C. 1, 0, 1, A, B bar, C. This is one kind of three variable common. We can also write this common like this. A, B, C. ABC like this.
0,
0,
1,
1, and 0, 0, 0, 1,
1, 1.
1,
1,
0.
Yes, sir.
And then that is
A bar, B bar, C bar.
yeah, A bar, B bar, C bar. A bar, B bar,
C.
C. A bar, B, C. A bar, B, C bar. A, B bar, C bar.
Yes, sir.
A, B bar, C. A, B, C. A, B, C bar.
Yes.
A, B, C bar. They are both right. They are both right. For four variable common, if it's a little complicated,
No problem.
0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 1, 0.
Lucky, we can try this one. We can try this one.
What?
We can try this one.
Okay.
No, not this way.
For verbal, you can write by yourself, make a try.
Okay.
One. No. Zero.
Sir,
Practice.
sir, I don't do like this. I do AB and BC.
Most is okay.
But you don't know.
But in general, we make the order A, B, C, D.
I know, sir, but this is okay.
Okay.
I find the BC and the D.
Okay.
Your honor is your honor. AB and C. What? Try to different one.
Okay. The four variables come
করলে
up
করছে এবি
like this.
সিডি করছো
In general, we make the order of
Try to
A,
different,
B,
man.
C, D. Secondly, you can also make the order of A, C, B, D, A, B, C, C. Can also, but in general, we use A, B, C, D. And then, on very important concept, adjacency. Cell adjacency. What does this mean? What does this mean? This means the two cells are adjacent. 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 Others are also similar. But also, these two cells are also adjacent.
Yes.
Why? Because the binary values of these two cells only have one bit difference. For example, this is 0, 0, 0, 0. Why? Right? 0, 0, 0, 0. And this is 0, 0, 1, 0. Only one bit are different. And these two cells, 0, 1, 0, 0. And this way, 0, 1, 1, 0. Only one bit are different. Right? Also, these two cells are adjacent. These two cells are adjacent. And these two cells also adjacent. Because 0, 0, 0, 0. 1, 0, 0, 0. The first bit are different. And these two cells are adjacent. These two cells are adjacent. These two cells are adjacent. So there are three variables. There are three products are adjacent to each cell. For 1, 0, 0, the adjacent cells are 1, 0, 1. 1, 1, 0. 0, 0, 0. For the three variables coming up, we know that for each cell, there are three cells are adjacent to it. For this cell, this one. The three cells are adjacent to it. But this one are not it is not adjacent to this cell. Because there are two variables. Two literals. There are two literals are different. Right? This is B-bar. It's B. It's C. This is B-bar. So the two cells are not adjacent. Only this one are adjacent to it. Only one single variable change. For 1, 0, 1, 0, 0, 0, 1, two variables change. For 0, 1, 1, 3 variables change. So only the first 3 product terms, only the first 3 cells are adjacent to this cell. That is the definition of adjacency. Adjacency is defined by a single variable change. Very important. Adjacency. Each cell is adjacent to the cells that are immediately next to it on any of its 4 sides. For 4 variable kernel map. Each cell is adjacent to the cells that are immediately next to it on any of its 4 sides. East, north, east, west, south, and north, right? 4 sides. East side, west side, south side, and north side. So there are 4 cells. 4 cells are adjacent to this cell. For these cells and this cell, they are also adjacent. So for this cell, the east side, west side, north side, and the south side. South side is this cell. So the 4 cells are adjacent to this cell. For this cell, the east side is this cell. The west side is this cell. And the north side is this cell. The south side is this cell. So for 4 variables kernel map, there are 4 cells adjacent to each cell. We call this adjacent. What we call this kind of adjacent. This wrap around adjacency. But for the diagonal side, a cell is not adjacent to the cells that diagonally touch any of its corners. For this cell, the 4 cells are not adjacent to it because they are in the corner. Okay, we know the kernel map, but how to kernel map SOP minimization? Use kernel map to simplify our expression, to simplify our truth table. The kernel map is used for simplifying Boolean expressions to their minimum form, or the simplest form. Or minimize the SOP expression to test the fewest possible terms with the fewest possible variables per term. Note that This is the minimized SOP expression, not the standard SOP expression. Not the standard. We use standard form expression to generate the column map. But we use column map to simplify our expression to the minimized SOP expression. To the SOP expression. Not the standard SOP expression. Because the proposed simplification is use the field gate. The field gate to form to represent the expression. So we first should mapping of standard SOP expression. The method is place a 1 on the column map for each product term in no standard SOP expression. And then there are two steps. First, determine the binary value of each product term in the standard SOP expression. And then each product term is evaluated. Place a 1 on the column map in the cell, having the same values as the product term. For example, mapping the following standard SOP expression on the column map. If we know the expression, how to get the corresponding column map? First, we know that there are 3 variables A, B, C. So we use the 3 variables column map, right? And step 1, binary value of each product is 0, 0, 1, right? 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 1. And step 2, place 1 on the column map on the corresponding cell.
A, B, C, 3 variables.
0, 0, 1 is this cell. 0, 0, 1 is this cell. So 1. And 0, 1, 0. 0, 1, 0 is 0, 1, 0.
0, 1, 0. This
is 1.
Second row, first row.
Yes. So this one is 1.
Yes.
And 1, 1, 0. 1, 1, 0.
This third row, first row. And 1, 1, 1.
Yeah.
And the third row, last one. Third row, second row.
Yes.
Yes, sir. 1.
1. And the other cells are 0. The other cells are 0. That is mapping the column. Another example, mapping the following standard SOP expression on the column map. There are 4 variables, so it is already complicated. First, binary value for each product. 0, 0, 1, 1, 0, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 1, 1, 1, 0, 0, 0, 0, 0, 1, 1, 0, 1, 0. There are 7 product terms. So there are 7 ones on the column. On the column. First, 0, 0, 1, 1. So there are 7 ones on the column map. And the other cells are 0, 0, 0. We can write the 0. Also, we can delete the 0.
Just type 1.
Yeah. Yeah. That is mapping the standard SOP expression on column map. If the expression is a non-standard SOP expression, we can also mapping it to the column map. The method is convert the non-standard SOP expression to standard form. For example, AB bar. If there are three variables in the domain, then the C is missed. So we must convert it to standard SOP form. So the standard SOP form is A B bar C A B bar C bar. Right. So there are two product terms, two standard product terms for this product term. For example, how to map the following SOP expression on the column map: A bar plus AB bar plus ABC bar. ABC bar. Do the exercise by yourself.
Okay.
answer. Is answer. A bar, if A bar equals to 1, it represents A bar equals to 1, that is 0, 0. So the four cells are 1. Because in the four cells, A bar equals to 1. Equals to 1. And for A B bar is equivalent to 1 0 1 0. So if A B bar is 1 0 1 0, then all the cells are 1. All the cells are 1. And this cell A B C bar 1 1 0. So this 1 1 0 equals 1. Equals 1. So that is the map of the expression. Okay, class is over.
1 minute.
Okay.